Welcome to another Facing Future program. We're coming to you today from Glasgow, Scotland, the COP talks. And I'm your host, Dale Walkinen. I'm the executive producer of Facing Future. Today we'll be looking at what's happening in the polar regions. And we have with us Peter Wadhams, Emeritus Professor of Physics, Ocean Physics at Cambridge University, and the author of A Farewell to Ice. We also have Paul Beckwith, a climate scientist, physicist, engineer, and educator affiliated with the University of Ottawa. The Arctic is heating 3 times faster than the rest of the world. Peter, you've been there on over 50 expeditions. How is that heating affecting both the ice, the permafrost, and the rest of the world?
Well, thank you. I'd really like to. That's a very difficult question because the ice is affecting many, many aspects of global climate. So I'm going to show a few slides which indicate the different ways in which ice, the very rapid changes that are happening to sea ice, are having a big impact on different aspects of the climate system. Okay, of course, like all scientists, I advertise my own work first. This is the book about the loss of sea ice in the Arctic and the Antarctic and what it's doing to the global climate. And if you'd rather see a movie, there's a very nice movie out called Ice on Fire, which was made by Leonardo DiCaprio and deals with every aspect of the loss of ice and what it means and how we can try to mitigate that by finding ways to take carbon dioxide out of the atmosphere. Now, this is all. The reason why this is all happening is because, as the advertisements say, you can't argue with the melting point of ice. That when the climate is warmed by the addition of extra carbon dioxide, the first thing it will do is melt anything that's frozen because it's a more rapid change that it can make. So we see this rapid change in warming happening from the CO2 record on Mauna Loa, which is showing an accelerated warming of the climate ever since measurements began in 1958. And this is a sort of a sneaky picture which shows the little markers along here are the dates of the different COP meetings, and it demonstrates that every COP meeting hasn't had the slightest impact on the growth of carbon dioxide in the atmosphere, although we hope that this one will, but if so, it's the first one that has had an impact. And as Dale has said, that one of the most important things about the Arctic is that it's warming about 3 times as fast as the rest of the world. And we see the area north of 60 degrees is very rapidly warming compared to any other latitude, north or south. And the consequences of this, the first consequence really is that the warming is causing additional melt rate for ice. This is land ice on the ice sheets of the Arctic, especially the Greenland ice sheet, and this is causing an enhanced rate of global sea level rise. So the first global effect that we see from ice melt is the global effect on sea level, and there's also effects in other ways, which I'll describe in a minute. This is the one of the other effects, which is the effect on the water mass in the shallow water areas around the edge of the Arctic. Now, in the meeting yesterday, we described this phenomenon, and it's really potentially a great threat to the whole survival of the human race, because what's happening is that in shallow waters around the edges of the Arctic, around the coasts of Siberia, the water is warming during the summer because the sea ice is disappearing. The sea ice is now in a core situation. It just survives in the centre of the Arctic. And around the edges we have open water. And because the water is shallow, that open water warms up. And when it does warm up, it starts to thaw out the very thick layers of sediment underneath, which are full of methane. They're in fact a methane hydrate, a solid material. And that material is protected from melt at the moment by a layer of permafrost on the seabed, but that layer is itself melting. And we can expect, therefore, the possibility of large methane outbreaks from the Arctic shelf seas. And that's something which I think is a big fear. We know that the sea level rise is going to be accelerating. All these sort of show how our successive measurements done on global sea levels show a rate of increase which is steadily increasing. We've always been underestimating, or we meaning the Intergovernmental Panel on Climate Change, has been underestimating sea level rise. But now we're expecting by the end of the century at least 1 metre of rise, and possibly much more than that, 2 or 3 metres perhaps. And we can see this is the record over the last few decades, and we see the inexorable rise in global sea level. One of the things that has done, that is related to that, is the disappearance of land ice from the ice sheets of the Arctic. And these pictures were taken on the 1st of August last year, or 2 years ago, when there was a record day of melt. I was up on the ice sheet and the air temperature was 21 degrees, which is not what you expect on the top of a high elevation ice sheet. But it caused a record rate of loss of ice through melt. And as the ice melts, one of the things that happens on these ice sheets is that the ice sheet gets to look darker and darker. And this phenomenon is called black ice. What it really is dirt and dust on the ice sheet, which remains behind when the rest of the ice sheet melts and makes the ice sheet surface darker and darker, and that absorbs more and more radiation. This is now enhanced by the fact that we have a lot of extra soot coming down onto the ice sheet from all of the brush fires that have been happening this year. And we see this here, the rise in the warming rate of the Arctic being so much higher than the rest of the world. That's the red part on the right. We see how that is going to result in much more rapid melt. One of the other things that is resulting out of this is very much more brush fires in a place where you don't ever expect to get them, which is Siberia. And Siberia now has had the highest area of brush fire anywhere in the world. And we don't know why that is, but it's certainly there, and it comes back each year because the fire remains smouldering underground during the winter. And if we look at some other effects of the warming of the Arctic, here we just see the air temperature of the world as a whole and see that is accelerating. But when we think about what we can do about this, most of what everybody says needs to be done is to reduce carbon emissions. And this is the notional effect of what would happen if we just did that. That's the red line. It shows that the world keeps getting warmer because we're still adding CO2. The green line is if we actually try to remove CO2 from the atmosphere, we can bring bring the temperature down, and we can bring it down even more if we use emissions control, which is the very bottom line there, where we're not only taking carbon dioxide out of the atmosphere, but we're we're trying to reflect more radiation back into space. And we hoped that Stephen Salter would be here today, who invented very much the most promising method for taking, doing this thing to reduce the warming of the world by reflecting more radiation. But unfortunately, he's ill today. This shows the device he's designed, which is called a marine cloud brightening drone system. It's an unmanned ship where the masts contain nozzles, very fine nozzles, where finely divided seawater particles are released into the bottoms of marine clouds. They make the clouds brighter, and the brighter clouds reflect more radiation and cool the climate. And he reckons that about 40 of these would be enough to really keep the Arctic cool, and about 200 will be enough to cool the whole planet. So it's a technique that will have a big impact on keeping the Arctic and the rest of the world cool if it's applied at a high enough level. And the danger is, at the moment, as with most of these techniques, is that it's not having the money spent on it to do it at the scale that's needed. The other way of trying to get rid of, reduce the warming of the Arctic and the warming of the rest of the world is to actually take carbon dioxide out of the atmosphere. And this shows a method used in California by a company called Blue Planet, in which the carbon dioxide is extracted, the air is pumped through a receiver which takes carbon dioxide out, but turns the carbon dioxide into limestone, which is a product that's very much in demand for cement and construction. And this shows nodules of this limestone that have been recovered from the carbon dioxide. I meant to bring some with me, but unfortunately I forgot. And this shows these nodules being incorporated in cement, and the result is a form of concrete which is carbon negative, as opposed to most concrete, which is highly carbon positive. And this has been used successfully in some large projects, like putting a new roof on a San Francisco airport terminal. And a similar method is used by a Swiss company in Iceland. So it looks as if there's a great deal of promise in removing carbon dioxide from the atmosphere and turning it into something useful. This hopefully will then, through general cooling, cool the Arctic at a greater rate and help ice to reform. And so I'll just end those slides and say, well, these are a few of the things that are happening, but of course the worst thing that's happening is the impact of Arctic warming and Arctic ice loss on Arctic animals, because we don't have many wild animals left in the world. I think all of you must have seen the famous slide of what are the biomasses of different types of creature on the surface of the Earth, and we see that 60% of the mass of living creatures on the Earth are actually domestic animals, cows, pigs, sheep. It's animals under our control that we eat. 36% is the mass of human beings, and only 4% is the mass of wild animals. So wild animals, which we think of as being very common, are in fact very rare, and the Arctic contains a large fraction of the wildlife that remains, with polar bears, seals, whales, and polar bears in particular are threatened by the loss of ice because they need to hunt seals on the ice, and if there isn't any ice, they can't hunt seals. So there's a direct threat to polar bears whose habitat is being reduced. So those are some of the things going on with the Arctic, which are all, I think, highly negative and can only be put right if we can find a way to restore the Arctic somehow.
Thank you, Peter. You always give us a very clear picture of what's happening in the Arctic, which we all need to understand. I'd like to, Peter touched on the polar bears, which have been, of course, the poster child for climate change for many years. The whales have been iconic. But at the base of the food chain is the phytoplankton. And as the water warms and is becoming more acidic due to carbon dioxide dissolution, the phytoplankton are endangered. This is a very serious problem. If we lose the phytoplankton, we lose the other animals. And when we lose the other animals, we lose the circulation of the water that's accomplished by the upwelling of it through whales. Paul Beckwith is a climate scientist who's going to talk to us a bit about the phytoplankton and what's happening with the circulation of the water and the ocean currents. Paul.
Yes, thank you. The phytoplankton are a vital part of the ocean food chain, right? They're at the base of the food chain, and they only exist in the surface waters because they need the sunlight to do their photosynthesis. And they need nutrients which are lacking in large parts of the ocean, and the number of phytoplankton has significantly decreased, over the last 5, 6, 7 decades. And it's actually measurable, from satellites. We can measure the chlorophyll and see the phytoplankton distributions on the surface of the ocean. But also, phytoplankton are vital for producing low-level marine clouds, which are highly reflecting away a lot of the sunlight, keeping the ocean cooler below. So with less of those clouds, we get more warming. The Arctic's key in the climate system. It's like the cornerstone of a bridge or a building. You pull out that cornerstone and the whole structure can collapse. So I've often talked about the Blue Ocean event, and this is coming to us very soon. So you could anticipate no sea ice for August, September, October, say in a few years after 2025. Add another year or two, and you have no sea ice for the July, August, September, October, November, and by 10 years after the first Blue Ocean event, it wouldn't be surprising to me if there was no sea ice year-round in the Arctic, and this would put us in a very different world. Canada alone its temperature has increased at double the rate, and Russia even more. Northern countries are, the higher up in latitude you go, the higher the warming. And if you go to the high Arctic, the warming there is 4 to 5 times faster than the average. And of course, the whole system is changing. The acidification is greatly increasing in the Arctic. The stratification, normally you have the ice, and then you have fresh water around the ice, and then there's a layer of freshwater lens, if you like, but it's salty, warmer water down below. So when you get mixing of the water in the Arctic, that heat from the ocean water down below can actually come up, and there's enough heat there to take out the entire ice above if the mixing occurred. There's also effects called Atlantification, where the water in the Arctic is becoming more and more like the Atlantic. More and more Atlantic water is entering into the Arctic at different levels in the water column. Also the same thing in the Pacific Ocean through the Bering Strait. Peter mentioned the wildfires on land, and we're getting, the Arctic is becoming a much warmer place, so we're getting a lot more rain events, a lot fewer snow events. That rain is going into all of the rivers in the north and then running into the Arctic, and there's lots of permafrost along the river pass, which is being thawed. Also, the coastal permafrost is being thawed. And with the more river runoff and sediments, all that warm water is going into the Arctic. So the Arctic is being hit from all sides. Now, Antarctica is interesting because it's, typically up to about a decade ago, the sea ice around Antarctica was increasing about 1.5% per decade. But in the last number of years, it's actually been dropping rapidly. And it's just, in the last decade it's been dropping, not increasing, and then in the last few years it started to rise again. So, there's a lot of complex dynamics that connect the poles. There's something called the bipolar seesaw, where one pole gets warm, the other gets cold, and those are in the paleo records. Now, Peter's mentioned marine cloud brightening as a possible way to cool the Arctic with Stephen Salter, who couldn't be here. Yesterday we had a session on OPR, ocean pasture restoration, trying to restore phytoplankton in the open ocean because iron is a lacking ingredient. We can get phytoplankton blooms there and pull a lot of carbon out of the atmosphere and generate more clouds. And there's loads of interesting ideas. I mean, mirror is another one that we've had a session on that, using mirrors to reflect sunlight and increase the albedo of the Earth to reduce the warming. So we have to slash fossil fuel emissions. There's no question. We should have done it 10 years ago, but we haven't. We have to do it now, but we also have to pull CO2 out of the atmosphere, and we also have to figure out ways to cool vital regions of the planet like the Arctic, so our climate system and circulation patterns of the Earth don't completely flip into unknown territory on us.
Thank you, Paul. Both Peter and Paul have talked about the fires that are affecting us. We also are witnessing stronger storms. The blue ocean event, when the Arctic is totally open and the albedo changes and the water absorbs more sunlight, will cause more waves and more wind as it crosses the open water. Peter is an expert in wave motion and in what's happening in terms of the stronger storms that we're going to get if we allow the Arctic to melt. Peter, did you like to say something about the wave motion?
Yes, well, way back in prehistoric time, in 1973, I wrote my PhD thesis on that, and which involved going around and measuring waves going into the ice, and then measuring what it did to the ice, which was partly causing the ice to break up into smaller ice flows, and partly the waves were just passing through the ice and then going on through into the interior. So that was how I found the ice back then. And of course, then it didn't seem to matter. It was just a theoretical problem. But in practice, what's happening now is very, very serious, because the retreat of the sea ice from the edges of the Arctic into the central core, it's having these two effects. One, which I mentioned, that it's allowing methane to be released from the seabed, which is a very great threat to our future. But also the waves, there's a wide, it's called a fetch, the distance that waves, the wind can blow over the sea to create bigger and bigger waves. And that fetch is getting bigger and bigger in the Arctic because the ice itself is shrinking, leaving a larger area for wave growth. So we're seeing larger and larger waves during the summer reaching the coast and causing lots of damage. And we've all seen pictures of Alaskan villages, and in fact we saw that last night when it was a group of Inuit here showing what's happening to their villages, that storms are now, plus the fact that the storms are acting on villages built on top of permafrost, which is itself melting, means that villages are being abandoned, houses are having to be moved inland at enormous cost. Also, the coastline is being eroded, and whole areas are being just washed away. So we can see the power of the sea is being able to exert itself because of the retreating effect of sea ice in protecting.
Thanks, Peter. It's not only the people in the north who are being affected, of course, by the polar melt. All of our climate systems will be affected. The jet stream will be affected. The Gulf Stream will be affected. All of our coastlines will be affected. We may have much colder temperatures in some places because the warming effect of the sea currents will change. And we may have some shocking cold waves as the jet stream pushes south at times. We've seen that happen, the polar vortex, which we've experienced in some places in the world. So it's affecting everyone, and it's a very critical problem because the methane underneath in the permafrost is, if it does get released, it's a disaster for us all. We have a few a minute or two left. Is there anything either of you would like to say that you...
I'll just add, just one quick thing about the global climate. So the equator is obviously warm, the poles are cold. Because of that temperature difference, air moves from the equator to the poles, and it gets deflected because of the rotation of the Earth, the Coriolis force, and that sets up the jet streams. About a third of the heat is carried to the poles by the ocean currents, and 2/3 by the atmosphere. And as the Arctic warms like crazy, and heats by itself because it's darker, there's less heat going from the equator up to the Arctic. So the jet streams become slower and wavier and stuck in place, and they cause these extreme weather events, which you can think of as weather wilding or weather weirding, or even weather whiplashing, where you go from one extreme to the other. So what happens in the Arctic does not stay in the Arctic. It's not like Las Vegas. Right? It affects the planet. Same with Antarctica.
Okay, thank you. Thank you all for coming. This has been a presentation of FacingFuture.tv. We want to thank our sponsors, the International Society for Ecological Economics, the Sustainable Population Australia, the Interfaith Center for Sustainable Development, and the Buddhist Tai Chi Tzu Chi Foundation, without whom this program would not be possible. I want to thank you all very much for coming today and for your attention to this very critical issue. Thank you.